Okay, so this is going to be section 8.2. We're going to be solving systems that have special cases, so we're not just going to get a simple X, Y, Z type of answer. We're not going to be getting that here, okay? We're going to be getting things like no solution or infinitely many solutions. However, we can't just with the infinitely many solutions. You'll notice that it's not just writing infinitely many solutions. There's actually a different way in which we're going to write our final answer. So first, let's get into the first one. We're going to be solving these the same way we did in 8.1. We are going to try our best to get a row echelon form as much as we can, and then you'll notice the last row will kind of just be all zeros, except for maybe like what it equals on the other side of the line, the augmented line. So let's start with example 1. We obviously know it's going to be no solution, but let's see how. So let me first write my matrix, okay, because the system is already in the order with all the x's, y's, z's, and then the constants. Line, 2, 5, 12. So the first thing that we're going to do is try and make sure, remember we want to get a 1 in the top right corner, top left corner, sorry. After that, you want to use that row to make zeros below it. So I already have the 1 in the top left corner, but I'm going to use row 1 with row 2, and then row 1 with row 3 to replace those. Now, in order to get the 2 to be a 0, I need to multiply a negative 2 to row 1 and then add row 2. You could also multiply a positive 2 to row 1 and then subtract row 2. It's really up to you. I just chose to multiply a negative. And then for row 1 times negative 3 and then add row 3, you will get a 0 in row 3. So when I do that, I will have 1, 0, 0. So 1, negative 2, line 2. When I combine everything, I'm going to get 0. Then I'm going to get negative 1, 10, and 1. And then you'll notice in row 3, you're going to get 0, negative 1, 10, and 6. Okay? Now, real quick, I just want you to notice this. Rows 2 and 3 have all of that in common, right? However, this is where things start to change. Okay? It basically, think about it as them saying negative y plus 10z equals 1, but it also equals 6. That's not possible. So what we're going to do, we know it's going to be no solution because of that, okay? But let's keep going trying to get it in row echelon form for now. And then I could show you another way of how you notice, okay? Just in case you didn't see that row 2 and 3 were that much in common. Let's try this. So I want the negative of row 2 because I really want a positive 1 in that spot. Line 2. Now it's 0, 1, negative 10, negative 1, and 0, negative 1, 10, 6. So now what I'm going to do is I want to make a 0. So I got the 1 here. Now I want to make a 0 below. So I'm just going to do row 2 plus row 3 because I just got the 1 in row 2, so I'm going to use row 2 to change row 3. So I have 1, negative 2, line 2. Then I have 0, 1, negative 10, negative 1. And then you'll notice you're going to get 0, 0, 0, but then you get 5. That last row happening like that is that special case, all right, where we know it's going to be no solution. Now, I know typically our last step would be to get a 1 here, right? However, the only way we usually get that 1 in the last spot is by multiplying a constant to that row, all right? However, in order to make the 0 anything else through multiplication, that's not possible. You can't multiply anything to 0 to make it 1. So we're just going to leave it this way. So what we're going to do is we're going to write out our system from here. Y minus 10z equals negative 1. And then I just have 0 equals 5. This here is your identifier that this is not true. Therefore, your answer is no solution. Please remember this symbol means no solution. Okay? It can't have any answer. So we leave it there. We don't actually have to back substitute or figure anything out. So that's the problem. Now what I'd like you to do, pause the video and try checkpoint 1 on your own. Okay. If you paused or did not pause, I'm just going to go into checkpoint 1 now. So we have our system. It is in the proper form, so I am going to write it as a matrix. -1, -1, -1, line, -5, 0, 1. So I already have the 1 in the top left corner. Conveniently, if I don't, we could swap with any row or multiply something to the row. And I'm going to do -2 times row 1 and add it to row 2 to make that 2 a 0. Then I want that 3 to be a 0, so I'm going to do -3 times row 1 plus row 3. And when I do that, I'm going to get for row 2, I'm going to get 0, 1, 1, and 10. Then in row 3, I'm going to get 0, 2, 2, and 16. Now I know in the last problem we saw, oh, but they should match perfectly. Well, if I did multiply a half to row 3, I would have 0, 1, 1, and 8. So everything's still the same with rows 2 and 3, just something opposite on the other side of the augmented line. But we don't have to do that 1/2. Okay? So now that this is good, we move on to row 2. We have the 1 up there already. It just worked out that way. So now I'm going to do -2 times row 2 plus row 3. And when I do that, row 1 is the same. Row 2 stays the same. And row 3 becomes 0, 0, 0, and -4. Now, if you decide to do 2 times row 2 minus row 3, you would still get the 0, 0, 0, but you probably got a +4 instead of a -4. That's fine. I don't care if the number's different, then you did something wrong. But if those numbers are the same for me as you, it's just all the signs are different, they're all flipped, then you just did it the opposite way of me, but you're still good. So I have it in row echelon form as much as I can. So now I'm going to write it as a system. And then I get y plus z equals 10. And then 0 equals -4. This part is false, therefore my answer is no solution. Again, remember that symbol with the 0 with the line through it is no solution. It is not a 0. 0 is a number. That is a solution. This is not a 0. It's no solution. Okay, so now let's move on to the opposite of no solution, infinite solutions. So let's just get right into this and start solving. So I already have it in the right form, so I'm just going to write 3, 1, 2, -4, -1, -3, 4, -2, 6, line 7, 2, 5. So I am going to swap. I'm going to swap rows 1 and row 2 because row 2 has the 1, and I'd rather that be in the first row. So I swap everything. And then I'm going to leave row 3 the same. Okay, so I have the 1 in the top left corner. Now I'm going to make zeros below. So -3 times row 1 plus row 2 and -2 times row 1 plus row 3 to make the zeros below. When I do that, I am going to get the first row to be the same. I'm going to get a 0 here. I'll get 3 minus, so -1, 10, and then 1. And then you'll notice in the other row we get the same exact thing. notice how rows 2 and 3 are completely identical. That shows you that this is going to be one of those infinitely many solutions kind of answers. But we can't just write infinite solutions like this and then just circle it and call it a day and move on to the next question. It doesn't work like that like it did in the past. Okay, so this is actually what we're going to do. Okay, I am going to, well, first I'm going to make a negative row 2. Okay, so 1, negative 2, line 2, because I would rather a positive 1 in that row 2 spot. So it's 0, 1, negative 10, negative 1. And then what I'm going to do from here is make a 0 below by doing row 2 plus row 3, because they already match with the opposite signs. And I'm going to get everything in that last row to be a 0. Okay? So let's think about this. When I go to write it as a system, I have x minus y minus 2z equals 2. I have y minus 10z equals negative 1. And then I just have 0 equals 0. Now, what I want you to think about is the fact that we have 0 equals 0. This is true, right? However, that third row usually gave us what variable answer? It gave us z. So really, this is telling us that z can be anything. Okay? Another symbol for that, you could use the symbol, so it's that. It's kind of like the paragraph symbol, but make it into an R. This means all real numbers. Okay? So z could be whatever it wants. Now, something to keep in mind, usually when we get an answer for z, we plug it in, we back substitute up, and we find our y, then we substitute that up and get our x, right? So what we're going to do for infinite solutions are, I'm going to still write my answer as an ordered triple, okay? However, I am going to try and rewrite y and x in terms of z, because x and y, this is very important, are dependent on z. Okay, x and y are dependent on z. So we are going to rewrite x and y in terms of z. So your final answer will only have the letter z in it. So I'm going to take the y minus 10z equals negative 1, and I'm going to isolate y. So I have to add 10z to get y by itself. And I get y equals 10z minus 1. So y is the same thing as 10z minus 1. Okay, and that's what we're going to put in our answer. Now, usually we use this kind of idea when it came to substitution, right? So I'm now going to find x. I'm going to put wherever I see a y, that 10z minus 1. And then minus 2z equals 2. So I got to distribute the negative. And now I'm going to combine my like terms. And now I will isolate x. So I move everything to the other side except for the x. And I get x equals 12z plus 1. So your final answer is going to be written as follows. 12z plus 1, comma, because that's where our x would be. 10z minus 1, comma, because that's where our y would be. And then just z. This is how we are going to write our final answers when it's that infinite solution kind of situation. I know it seems a little weird, but we got to write it this way. Okay? This is for infinite solutions. All right. So let's move on and do checkpoint 2. Pause the video. If you feel like I'm moving too fast, remember you can pause at any time you want, but try this out on your own. Pause the video. Okay. Hopefully you pause the video. So, let's do checkpoint 2. So I'm going to write it as a system. not as a system, it's already a system. I'm going to write it as a matrix. 1, 2, 1. Then I have negative 2, negative 5, negative 3, negative 1, 3, 4, line 5, 6, 1. So I already have the 1 in the top left corner, so less work for me to do. But I need to make zeros below, so I'm going to do negative 2 times row 1 plus row 2. And then I'm just going to do row 1 minus row 3. You could have also done negative row 1 plus row 3. It doesn't matter. But they both had 1s, I just subtracted. So I'm going to get 1, negative 2, negative 1, line 5. For my row 2, I'm now going to have 0, negative 1, 5, negative 4. And then for row 3, I'm going to have 0, 1, negative 5, 4. Okay, so you have a few options here. You can swap rows 2 and row 3 like so, and have the positive 1 up top. However, it's already a negative 1, right? So just do negative of row 2 so that you don't have to worry about messing up any numbers. So negative 1, line 5, 0, 1, negative 5, 4, and then 0, 1, negative 5, 4. Again, rows 2 and 3 are identical, so we know we're going to have that infinite solution kind of situation. So I'm going to do row 2 minus row 3 because they're the same. And when I subtract something that's identical from the other, you're going to end up with all zeros. So 0, 1, negative 5, 4 for the second row. Then we have 0, 0, 0, 0. I got in row echelon as much as I possibly can. So now I'm going to write it as a system. X minus 2y minus z equals 5. Y minus 5z equals 4. And then 0 equals 0. Here's my system. So this little bit here tells me that z can be anything it wants, any real number. However, we want to rewrite y and x in terms of z. So y minus 5z equals 4, so I'm going to add 5z to both sides, and I'll get y equals 5z plus 4. Now for x, it was x minus 2 times y, which is 5z plus 4, minus z, don't forget that little extra bit in the formula, equals 5. I'm going to distribute the negative 2 into the parentheses, and I'll get x minus 10z minus 8 minus z equals 5. Combine my like terms, x minus 11z minus 8 equals 5, and I'm going to add 11z and 8 to both sides. X equals 11z plus 13. You could have also wrote it as 13 plus 11z. It doesn't matter as long as the sign in front stays with the sign in front. I don't mind. So my final answer is going to be my x, which is 11z plus 13, my y, which is 5z plus 4, and then z. Okay. Hopefully you're feeling alright with this. One of the more common mistakes within this formula is that people forgot this minus z here when doing the x. Just be careful that you write everything down. Okay. Now, dependent solutions. It's basically the same as the infinite solutions, okay? I know we're used to seeing systems where, let's say I have x, y, and z, 3 variables, right? I usually have another equation down here, right? I usually have, if I have 3 equations, I have 3 variables. If I have 4 equations, I have 4 variables, right? If we have more variables than letters, more variables, letters are variables, than equations, it's going to end up being just like the infinite solutions kind of thing, okay? So our system here is going to be 3, 1, our matrix, sorry, I keep saying that, 7, 2, 6, 1, line 26, 8. This is our system, right? If you wanted to, you could put 0, 0, 0 equals 0. However, it's not necessary. Why put another line? So I'm going to swap rows 1 and rows 2 because the row 2 has the 1 already. That should be an 8. And then 3, 7, 6, 26. So I need to now get a 0 below that 1. I need to change that 3. So I'm going to do negative 3 times row 1 plus row 2. And when I do that, I'm going to get 1, 2, 1, line 8. And I'll get 0. Negative 3 times 2 is negative 6 plus 7 is 1. Negative 3 times 1 is negative 3 plus 6 is 3. And then we get 2 here. Now, as crazy as it seems, we already have it in as much row echelon form as we possibly can with our 1 diagonal and zeros below it. So I'm actually going to write this as a system. Okay, now the first row usually gives us our x answer. The second row gives us our y. Since we don't have a third row, we're going to assume what we did with the infinite solutions. Okay, again, it's like having that 0, 0, 0, 0. So we're going to say that z can be anything it wants, all real numbers. So again, I'm going to isolate x and y and write it in terms of z because they're dependent on z. So y plus 3z equals 2. I minus 3z. And I get y equals negative 3z plus 2, or 2 minus 3z. And then x plus 2 times y, so put in the negative 3z plus 2, plus z equals 8. I distribute the 2. I get x minus 6z plus 4 plus z equals 8. I combine my like terms, so I get x minus 5z plus 4 equals 8. And I add 5z and minus 4 to both sides. And I get an x of 5z plus 4. So final answer, 5z plus 4, negative 3z plus 2, and z. Very straightforward lesson. Now I want you to pause the video, try out the last checkpoint. If you get it, you should feel very comfortable about this. The homework for this assignment, for this lesson, is now back to being on MyMathLab. Okay? So, no more paper homework, all right? Just having it on Pearson. So, pause the video and try this out. Okay. So, 1, 1, 2, 1, 3, 1, line, 70, 60. So, I wrote my system as a matrix. And they already have the one up top, and they already match, so I could just do row 1 minus row 2. Easy enough. So 1, 2, 3, line 70. And then 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 70 minus 60 is 10. I'm already done, as crazy as that is. So, x plus 2y plus 3z equals 70. And then y plus 2z equals 10. So since there's only 2 equations and 3 variables, I'm going to say that z can be anything it wants. And I'm going to solve for y and x in terms of z. So y plus 2z equals 10. I'm going to minus 2z to both sides. So I get y equals 10 minus 2z, or negative 2z plus 10. It doesn't matter. Pearson's going to mark you right regardless. I just like putting the letters first. It's just something I do. So x plus 2 times negative 2z plus 10 plus 3z equals 70. Distribute the 2. And I'm going to combine my like terms. So it's x minus z plus 20 equals 70. And I will now isolate x. So minus 20 plus z. So I get an x of z plus 50. So your final answer should have been z plus 50, negative 2z plus 10, or 10 minus 2z, and z. That is lesson 8.2. If you really got the hang of the matrices over the past 2 weeks, you're going to do great on this lesson. I guarantee it. Look out for the video on 8.3. That is also another easy lesson. And email me if you have any questions.